Hello, everybody. Let me load up the chat room. Live stream is starting soon. All right, so let's get into that room with all the live people. Loading, loading, loading. Oh, all the loading. Live streaming, events. Boom, I'm in the room. There I am. All right, cool. All right, hey, hello world. It's Siraj. Good to see everybody. I'm gonna list some names. Collins, Sycut, Ricardo, Spencer, Daniel, Preston, Nawal, Happy New Year, Sagar, Shazan, Lance, Xavier. How's it going, guys? Okay, so today, it's good to see you guys. Good to be here. I'm excited for this live stream. Today, we're going to build, well, first of all, we're going to install OpenAI's Universe, and then we're going to build a game bot to get better at it. And it's our own custom game bot. It's going to be about 70 lines of code in Python, and then I'm gonna along the way I'm gonna explain how it works. Okay. So first of all, as always, I'm gonna start off with my 5-minute Q&A, and then we're gonna get started. All right. All right. Here we go. How much math you know behind all this AI and ML? I've studied linear algebra. I've studied statistics and calculus. In terms of how much do you need, I think I mean it depends on the level that you're trying to you know what you're trying to do. If you're trying to do research, you definitely need some math. It's no question. If you're a developer and you're just trying to implement some machine learning into your app or use an API, you obviously don't need math. And if you want to do something in the middle where it's like you're a developer, but you're also you're doing some innovations in AI, having some math is good. And I'm gonna start teaching more math on my channel. All right. Hi, Alexander in Macedonia. What do you do for a living? I do this channel full time. How do you get started with TensorFlow? And say my name, please. Rajat. Started with TensorFlow. I have an intro to TensorFlow series on my channel. What is OpenAI Universe capable of other than games? Great question. So there are environments. There are environments for doing tasks like sending an email or doing some kind of mouse clicking keyboardy event. So there's a lot of different set objectives, and they're adding more over time because it's open source. Can we get TensorFlow working with Golang? There's got to be a wrapper on GitHub. Just search TensorFlow and then click on Go. Tell me if something shows up. I actually haven't searched for that. I haven't even thought of that. You're doing a great job, Sarah. Thank you. Thanks, Bartos. Which is the best tutorial to learn Python to be efficient at ML? I have a series called Learn Python for Data Science. Check it out. When will the basic deep learning video series come out, and will it also feature the math? Yes, it's coming out on Friday. It's something really big. Something really big is coming out on Friday, guys. So it's a lot of pressure, but this is going to be something really big on Friday. How long will it take this video? It's going to take about 45 minutes. Hi, Siraj. Are Google not releasing their best TensorFlow library? No, I mean, Google does have a lot of internal code that they're not going to share with us. But TensorFlow is that's a good portion of what they have. Are you going to make a GAN live tutorial? That's a great idea, David. GANs are really, really, really cool. And I made one video called Generative Adversarial Networks, but I'm going to do more. All right, so 3 more questions. Where are you now, Siraj? I'm in my room in San Francisco. What do you think about Mark Zuckerberg AI? I talked about that in like 2 streams ago. I thought of, all right, are you going to write code with you? Yes. What do you think about Pandora bots? I haven't heard of that. All right. Will you do something with videos? I guess you're talking about machine learning with videos. Yes. Is a nano degree worth it? Yes, I think it's worth it. And speaking of nano degrees, something cool is coming out. So just I'm not gonna say what it is. What college did you go to? Columbia. Do you smoke marijuana? Yes. And no apologies. So anything with D3.js and AI. I have a live stream called well, that's a visualization without AI. Anyway, Cool. Hi, Lordius. All right, so that's it for the 5-minute Q&A. Let's get started with this. We're going to install OpenAI's Universe, and then we're going to build our game bot with it. All right. So let's get started with this. I'm going to go ahead and start screen sharing. So obviously, it depends on your environment, like what you're running. But in this demo, we're going to let me just start screen sharing. Here we go. Screen share. Desktop. Okay. So here we see the actual repo, right? This is the repo for OpenAI's Universe. They've got a README here, and they're explaining that it is a software platform for basically training an AI in thousands of different environments. They've got Flash games, they've got browser tasks, as you can see here, like sending emails and more trivial things like that, and even like things like Grand Theft Auto 5, which isn't included yet, but it's coming very soon. And more games like that, 3D games, are going to come soon. So there's that, and then it's got the install instruction. So what I'm going to do is I'm just going to go through these install instructions with you guys, and I'm going to do it for Mac because obviously I'm on Mac, but this also applies to Linux. And if you're on a Windows machine, so the intersection here for Windows machine is when we talk about Docker. Okay, so we'll get there. So let's start off by installing Universe. Let me check what you guys are up to. Cool. All right, cool. So here's what we're going to do. The first thing we're going to do is clone the environment. So what I did is I went ahead and I'm going to open up Terminal, okay? And I'm going to say, let's see, I'm going to create my, let me make this bigger. Let me make it way bigger. Fun 5, CD Fun 5. Okay, so I'm in my directory right now. Okay, so let me make it super big. Okay, I'm going to make it super big for everybody. Everybody can see that? All right. Here we go. So here's what we're going to do. I'm going to put this over here. Let me see what you guys are up to. All right, cool. All right, so let's install this baby, all right? So we're going to start out by cloning this thing. Let's go ahead and hit clone, git clone. All right. So that's going to download it. Boom, that was fast. All right, so next up it says CD into Universe. All right, we'll CD in. All right, we're in our. Let's look at what it looks like. This font size is all right, guys? This font size is all right. Cool. Right. Okay, so we seeded into Universe, and now we're going to install our dependencies. So what is this line? It's the -e variable means in editable mode. All right, so we're doing this in editable mode, which makes installed packages editable. And it's reading which packages to download from setup.py. So you see this setup.py file here? Let's like nano into this for a second and just like see what this looks like. Setup.py is a list of the dependencies, and you can see them right here, like Pillow and Gym and Docker, Pi, things like that. All right, so that's what that is. So we're gonna go ahead and run our install line, pip install e. So that's gonna install. It's gonna download this dependencies from. All right, yes. I need to be in sudo mode, right? Permission denied. I was just denied access. That always happens to me. All right, so we got our dependencies, right? All right. Pillow gives you nightmares. Well, yeah. Anyway, okay, so we've got our dependencies, and so then it kind of splits off into whatever platform you're running. On Ubuntu, you'll want to install NumPy, and just in general, you should just have NumPy on your system because pretty much everything in machine learning is using NumPy these days. And then you're using apt-get to install Golang, and we on Go, and you're going to need Golang because we're using that for our VNC driver, which I'm going to talk about in a second. So for us, we are so us as an OS X users, we don't have a package manager like apt-get, so we have to use something called Homebrew, which, by the way, the inventor got rejected from Google for not being able to do. I don't know if you guys heard about that, the red black tree. This was like a year ago, but just thought that was hilarious and a good commentary on the state of programming interviews, which I still have to make a video on, how to ace a programming interview. I know you guys want that, so that's going to come soon. I just have a lot on my plate right now, so that's coming soon. Anyway, so for OS X, it's going to say you're going to need command line tools, which I already have, so I'm not going to run that. But so there's that, and then right. So and I have these dependencies. Right, so I'm just going to go ahead and just install them anyway. So I'm going to overwrite what I already have. Boom, I've got that. And then I'm going to use Homebrew to install Golang and LiveJPEG Turbo, which is going to help with like image processing, right? So it's going to update Homebrew. It's going to download these packages, okay? All right, so for Windows 2, all right, so now we're on, so we've got those dependencies, and now we're going to install Docker. So let's talk about Docker for a second here, okay? People need to understand how awesome Docker is. So this is the Docker website, okay? So this is how we install Docker, and depending on what operating system you are, there are different install processes. I recommend the binary, whether you're on Windows or Linux or Mac, you should use the binary because it's just easier. It's like a one-click install. But there's also, you can install from source, but I would prefer, my preference is binary. Okay, see, I've installed the binary Docker, and so like right up here, you see Docker is running. It's just running up there. I've got, I can get my diagnostics and preferences, and I can update them. It's a little pretty GUI, and that's fine. But so let's talk about Docker for a second, all right? So Docker is, so let me explain what Docker is. So, okay, so what's a good analogy? Docker is kind of like a TV dinner, okay? It comes in a box. It's got everything you need right there in the box, and when you're done, you just toss it away. Okay, so Docker is like it tries to make apps like TV dinners, and so virtual machines are kind of like that, but they're not quite the same. So it's like, so let me write this down. So like, what is Docker? Docker. So let me make this bigger. Okay, so let me make way big. Docker is like a TV dinner. Okay. It's got everything you need loaded in a meal, all in one, right? So Docker, it's kind of like a virtual machine, except it's less bloated than a virtual machine. So like a virtual machine, but thinner. So it doesn't have the bloat of a virtual machine. So virtual machines typically include an entire operating system, but a Docker ecosystem has a central engine that can run multiple Docker containers. So it cuts out the bloat of having multiple operating systems and it just packages the runtime elements that you need. Okay, so it's just the runtime elements that your program needs. And Docker's awesome because it removes like all the dependency hell that comes with every app. Someone suggested I Dockerize literally everything I do from now on, which I will seriously consider. I need to get better at. So that's a short primer on Docker. Okay, so in terms of Docker, we're going to install Docker, and a TV dinner is Docker. Okay, so we've installed. So we're going to install Docker, and remember, run the binary for Docker, and so once you've installed the binary, I'm not going to reinstall the binary for Docker. It's literally just like a 3-step process, like next, finish. But once you've installed the binary, it should be linked to your terminal. Okay, so you'll be able to call it from terminal. Okay, so and that's it. So Docker was the last step for that. And once we have that, we're going to go ahead and create our agent. So they've got a sample agent here, but we're going to go ahead and just create our own. Okay, so we're going to write up. So we're gonna go ahead and write up our script. We're just gonna go right into it. Okay. So let's go ahead and get started with this. Okay. So the first thing I want to do. So let me talk about what this agent is going to do. It's going to do 2 things. Well, first of all, the first thing it's going to do is our bot will do 2 things. The first thing it's going to do is determine should I turn, right? And then the next step is going to be where to turn. That's it. It's a 2-step process, where to turn. Okay, and this is going to be for the Coaster Racer game. Okay, which you can see right here. Okay, this is the Coaster Racer game. It's not going to be this default agent right here. We're going to build our own thing. But it's going to be, right, so, and by turning, I'm talking about which direction, right? Left or right? Which direction do we want to go, left or right? And that's what our bot will do. It's going to be about 70 lines of code, and it's going to decide where to turn. Okay. All right, and yes, it's reinforcement learning, and I'm using Sublime Text. You guys are all awesome as well. Thank you. Okay, so let's get started with this. So the first step, as always, is to import our dependency. So the first one is going to be Gym. Why are we importing Gym if we're using Universe? Well, Universe is based off of Gym. Gym was OpenAI's original attempt at creating an environment to run bots in. And they had games like cart pull, they had things like that, but Universe basically expanded on it like way more. So we're going to import both, okay? And so we've got both of those dependencies, and then we're going to import random because we're going to implement a random policy here, but it's going to be a smart random policy that's using reinforcement learning. Okay, so I'll talk about that in a second, but those are our only 3 dependencies. All right, those are our only 3 dependencies, and now we can go ahead and create our main function, all right? Our main function. The first step is going to be to initialize our environment, okay? So we'll say, what is our environment going to be? Like, what is the game that we want to play? So Jim has a make method that lets us define what the environment is going to be. And I'm going to define it right here. I'm going to say this is going to be a Flash game called Coaster Racer. It's a Flash game called Coaster Racer. And I think this might be a little too big, so I'm going to just go down a little bit. Okay. So that's what it's doing. It's initializing our environment, and it's going to be Coaster Racer, okay? So that's what that is. And let me so a little primer on what's happening here. So this is going to initialize our universe environment, and initializes universe environment. And what does that mean? There are 2 things happening when we're initializing our environment. There's a client and there's a remote. So the client is a VNC environment. That's where the agent lives. A VNC is a stands for virtual network computing. So when I was 16, I like a little script kiddie, I used to hack into these just for fun. But basically, it's a way to share desktop screens with 2 people. So you can if you're using the VNC is kind of like a protocol. It lets you see what's happening in another computer, right? And so the reason they're using VNC is because these games are running inside of this essentially a virtual machine, but it's a Docker container, right? It's like an operating system inside of a Docker container, which we're going to see in a second. So VNC is the way it communicates, and so it's a client and a server. And so the client is the agent. Sorry, not a client and a server, a client and a remote. The client is the agent. That's what's running that's what's deciding what the keyboard and mouse actions are going to be. And then the remote is the environment, and the remote is going to be local. I know it's weird that it's called remote, but it's local. It's our local Docker container. Now, if we wanted to, we could upload this to a server and then have it all run there. And in fact, we can actually say we want multiple Docker containers. So we can have multiple games running, right? So one agent that's playing multiple games at once. But for this demo, we're going to have this run locally, and it's going to be a local Docker container, right? So that's a primer on what we're doing with the environment. So now the next step is to get our initial set of observations, right? So right when the game starts, let's get the initial set of observations by running the reset method, okay? Which will initialize our environment. Okay, so that's the steps for initializing our environment. Now we're going to initialize our variables, okay? So we're going to initialize our variables, and the answer to life, congratulations. Okay, so Illuminati confirmed, always. So we're going to initialize our starting variables. What are these starting variables? Well, they're the number of game iterations, and we're going to define these later, but we're going to start off with 0. Both of these define the number of game iterations. So num of game iterations. Okay, so that's what those 2 do. And then this one is going to calculate the sum of our observations. So how many observations do we have? And we'll store that in the total sum variable, which we'll initialize as 0. Okay, so that's for total sum of observations. The next one we want to create is the previous total sum, right? And why do we want to do that? Well, we're going to compare both of those. We're going to compare the total sum of observations to the previous one when we implement our policy. And this is probably the most important variable, the turn variable. And we're going to, based on whether or not this is true or false, we're going to turn, okay? Because remember, this is a driving game, and there's only 3 moves to make: turn left, turn right, or go forward, okay? So speaking of turns, let's define our turns. Define our turns, or keyboard actions, okay? So let's define our turns, or keyboard actions. We'll start off with left, okay? So this is going to be a left turn. So a left turn is, so we're going to say our key event is arrow up, true, And let me explain this in a second, but let me just write this out. So that's our first key event. And then our next key, so let me just copy and paste that because I'm going to be reusing this, right? So our next one is key event arrow left, which is going to be true. And then our last one is going to be key event arrow right, which is going to be false. Okay, so there's that. So let me just copy this whole thing. Let me make this a little smaller so we can see what's going on here. A little bit more. Event, arrow left, arrow right. Bop, 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 bop. All right, so right, so that's for left, and I want one for right. So that's for left. So arrow up is true, arrow left is false for this right one. And then it's going to be true for going right. And then the last one's going to be forward. Those are our three key positions, left, right, and forward. And so for forward, it's going to be true, false, false. Okay, so let me talk about what this is. Okay, so we've got three key events that we've defined here, left, right, and forward. And so why are we defining three different key events for one direction, like left? Well, we want these to, so these are going to, these are a set of actions, right? And we want them to be like this because they're going to happen synchronously. They're going to happen synchronously. So whenever this is true, we want this to be false. Or whenever this is false, we want this to be true. So it's a format that we want to specify everything in, right? So we're just standardizing this format. We could easily just say, well, key left is just going to be, key left and none of the other two. But we want to standardize these so they're all in the same format, okay, as we iterate through them for a game. Okay, so it's for formatting purposes. In a nutshell, it's for formatting purposes. Okay, let me see what everybody's saying up here. Area Ubuntu, Gentoo, cool. Okay, so how do we interact with the pixels characters of the game? Great question. So the pixel data is returned via the observation variable when you run the environment's step method, which we're going to talk about in a second. But right now, let's go ahead and run our main logic, okay? So we've defined our terms, and so we're going to make a while loop here. So while true, we're going to run this thing. So this is just going to run continuously. So that's for the while loop. So now we're going to increment a counter for the number of iterations, okay? So this is our counter. So n we've already defined, but we're going to add 1 to it because, well, we're iterating, right? We just started the game and now we've iterated it by 1. So if at least 1 iteration, then check if a turn is needed. Okay. So now comes the fun part. So let's check in our observation variable, and we want to. So we want only the first observation from this observation variable, which is essentially a list. But we only want the first one because we don't. We say 0 because we don't have multiple games running, right? We only have 1. So that's going to be the first and only item in that list. Okay, so if there's something there, as in we've observed something, then it's time to check if we want to make a turn or not. So we've got some feedback from the game, and now we're going to store the reward in the previous score. So in the previous score. So we're going to say, okay, we've got this variable called previous score, which we've defined previously, right? And it's just going to serve as a way for us to compare what we have now to what we had before. And we're going to use that later, that comparison, okay? So we've got something from the game, right? We're still in this if statement. We've observed something, right? So now we're going to check, okay, is it time to turn? Remember, turn was initially set to false. But if it's true, and we're going to determine whether or not we want to turn in a second. We're going to create a function for that called determine whether or not we want to turn. But if assuming it's true, then we want to pick a random event. Okay. So the event is going to be hold on. The event is going to be it's going to use that. And remember, we imported that random library up there, which is going to help us with this. So random.choice. Pretty aptly named, right? So random choice is going to be an array of left. So we're going to choose between going left or right, and that's going to be the event. So based on whether or not we turn. So remember, there are two things happening here. So should we turn? So that's what should we turn, and then where to turn. where to turn. And so this answers the question where to turn, but we still haven't answered the question should we turn. And that's where the reinforcement learning comes into play. And I'm going to talk about that in a second. But let me check if everybody's following. AI is so volatile. Seems everybody's cool. All right, cool. So where to turn is the next thing. Okay, so now we're going to perform an action. Let's perform an action. So we're going to perform an action. So the action is going to be, we're going to call it n, right? So so for the event, okay, so let me just type this out. Event for opt-in observation n, okay? And then we're gonna right. So we asked, should we turn, and then where to turn. We got that event. It's going to be either left or right, and then we're going to perform an action based on that event. So based on whatever we see, perform that random event, and that's going to be encapsulated in this action variable, right? Whether or not we want to turn right, it's going to encapsulate it in this action variable, which is going to be the input to our step method. We haven't actually implemented this action of our choice to randomly turn left or right. We've only defined it. Okay, so now we've done that. Let's set turn to false again, because remember it was true in this case. So now we're going to set it to false again, because guess what? We already turned. Okay. So now in the opposite case, let's see. So so guess what, guys? So I missed one thing here. So the one thing I missed was saying, I've got this observation. So if n is greater than 1, so if at least one iteration has been made, right? So which I've already incremented, if at least one iteration is made, check if turn is needed, right? So if at least one iteration is made, let me add that there. That means that all of this has to be indented. Boom, boom, boom. I'm going to go ahead and indent. Okay, so I've indented everything. And now I'm going to check in the opposite case. So if not, so else if not turn, okay? So if no turn is needed, so let me write that out. If no turn is needed, go straight, right? So if no turn is needed, and I still haven't determined, this is coming up, like, should I turn or not? And that's going to be the big reveal. Like, how do we know whether or not to turn? And that's the reinforcement learning step. So the action we're going to get is going to be forward, right? Which we've already defined based on whatever we see in our observations. Observation _ n, right? Okay, so there's that. And then if there is an observation, the game has started, and check if a turn is needed or not. The game has started. Check if turn needed. All right, so if there is an observation. So if observation, hold on. Man, words are hard. Observation n0. Sorry, no, n0. Everybody's following? Everybody's following? Everybody's good? Everybody's good. All right, great. Okay, so observation n, if it's not equal to none. Okay, so if there is an observation, game has started, check if a turn is needed. So now we're going to run our function that we're about to define with our reinforcement learning logic. So total sum. So here are the variables that we're going to get back from this. So total sum, previous total. These are our variables, and we're going to define what each of these do. So there are going to be 4 variables that we get back. So total sum, previous total, sum, j, and then determine turn. That's the name of our function that we're going to define based on whether or not we want to turn, based on what we see in our environment, the observation, and in that first environment, and the only environment, which is why we say z. J is that iteration variable that we defined earlier. the total sum, which is the total sum of iterations, and then the previous total sum, which is our way of comparing. Okay? Oh, and there's one more. So the reward. Those are what we're going to use. Those would be 5 variables we're going to use to determine whether or not we should be turning. Okay? So there's that. Okay. Boom. That's a big variable. Okay. I mean, sorry, a big line or function. Okay. So then we're going to save the new variable for variables for each iteration. So now we've determined. So this is the end game, right? We've run our reinforcement learning. We've determined that yes, we want to turn, and that where we want to turn, right? We solved our 2 questions, and now we're gonna implement that turn or that action, which is a turn, right? And it's gonna return our 4 variables, right? That OpenAI gives us whenever we run the environment's step function, which is a time step, right? So it implements the action, right? So that the action that we defined up here, okay? And then the last step is to render our environment, right? So we're always rendering it. We've got to render it for every time step, okay? And then obviously we'll have this like ending code, which is like if the name, and what was it? It's like equals under main, and then if name, then main. Okay, so there's that, and now we're ready to actually create our determine turn step. So this is the reinforcement learning step. Reinforce. So let's see. Hold on. This is our reinforcement learning step. Reinforcement learning step. Let me check if everybody's on board. Reinforcement learning step. Okay, so it's going to be called def determine turn. Okay, let me check if everybody's on board real quick. Let's see. Main. Thank you, Rodrigo and Shubham. Okay, so let me make sure. Right. Okay. Okay. So now we're ready to determine our turn. Okay. Okay. So let's go ahead and write this step. Okay. So turn. So remember, what are our variables? Well, we define those down here. The observation, the reward n, and the previous total sum, the total sum, observation n, and then the turn. So these are our variables. So I'm just going to copy and paste those, right? Because we already defined them. And well, we don't need to add this because we don't need to add this index counter because it already knows that. We're just going to make it something a little more pretty. Okay, so now we're ready to run this variable. So okay, so here's the basic logic. So for every 15 iterations, sum the total observations, okay, and take the average. That's what we're gonna do. We're gonna take the average. If it's lower than 0, change the direction. Okay. So that's what we're gonna do. Okay, so that's what we're gonna do. And right. So basically, what this means is like it's gonna use the reward as a pointer. It as a guide. So if basically it's saying that if you've gone for 15 iterations and so let me just write this out. So if we go 15 iterations if we go 15 iterations and get a reward each step, we're doing something right. We're doing something right. So that's when we want to turn. That's when we turn. Okay. So that's the basic logic. Let's go ahead and write this out. So if j is greater than or equal to 15, right? So j is going to be our reward, okay, for this step. Basically, it's saying, okay, if you've gone 15 iterations or more, sorry, it's 15 or more, sorry, 15 plus iterations. So if the total sum of the iterations, so if the total sum, which is the reward, is the same as the iterations. And how do we define sameness? Well, sameness is going to be a division, right? If they're the same number, as in there's no remainder, then turn is going to be true. Okay? Turn is going to be true. Else, well, if it's not the same, as in, well, you haven't gotten a reward for every iteration, you've actually crashed sometimes, then turn is going to be false. Okay, so this is how it's reading the reward. It's using the reward as a guide to determine whether or not to turn. The actual direction to turn is random, but the reinforcement learning is using the reward to determine whether or not to turn. Okay, so we still haven't defined the reward yet, so that's going to come up. So assuming that we've done this, we've already defined, whether or not we want to turn. We can go ahead and reset these variables because we've already defined them. They've played out what we wanted, and we're going to go ahead and reset them. Okay, so that includes the sum of rewards, the iteration count, and also the previous total. And so the previous total, that this is when it gets that the value of the total sum, because we've reset the total sum, and now the previous total is going to get what happened before. Okay, and it's a way of storing what we had before, just so we know what we had before. It's good to give a counter of that, and we can extend that too. Okay, so let me make sure everybody's following. All right, thanks, Frank's World. All right, cool. All right, cool. So, previous total sum. Okay, total sum equals 0. Okay, so else, we're going to say turn is false. So basically, this is the else. So this is if we're not receiving a reward every 15 iterations, then we're gonna say, okay, so don't turn. Okay, and so now we want to define. Now we want to define whether or not we want to. Hold on. Now we want to. Let me make sure. Empty white space, not necessary. Keep it clean. You know how it is. You know what it is. So if we have an observation, and if we have an observation, and there's something there, right? If there's something there, then we're going to say, okay, we want to increment the counter. That's which we're comparing above. We're going to increment the counter and the sum, and the reward sum. Okay, so let me write this out. So j plus equals. So this is our counter. J plus equals 1. And then total sum plus equals reward, n. And then total sum reward n. Okay, so now we're going to return turn j total sum, everything that we calculated here, and that's it. Okay, boom. So let's go over what happened here. Okay, so okay, let's go through this step by step. We initialized our environment and then a set of variables, right, that we were later going to use. Okay, then we defined 3 actions, right, 3 keyboard events: going left, going right, or going forward. Okay, and so because that's all we're going to do. So then we started this while loop because this is just going to keep on running as forever. And we said, okay, so let's increment our counter because, well, this for every step that we're running. And then we said, if our game has made at least 1 iteration, check if we need to turn. And so, okay, so assuming that we've made at least one iteration, so the game has moved 1 time step, and we have something that we're seeing, right? The observation of the game, which depends on whatever game we have. We're going to store the reward in the previous score and then determine if we should turn or not. So if we do turn, then we're going to pick a random turn. So either left or right, encapsulate that inside of an action variable, and then set turn to false again because we've already done our action. Else, if no turn is needed, just keep going straight. And this is how we determine whether or not we want to turn with this determines turn function, and we use those variables we defined previously. And then we actually implement that term as a turn as an action using the environment step function. How do we determine whether or not we want to turn? Well, for every 15 iterations, we sum the total observations and we take the average. If it's lower than 0, we change the direction. If we go 15 plus iterations and get a reward at each step, we're doing something right, and that's when we turn. That's our signal, right? And why 15? Well, it could be 16, it could be 17. It's arbitrarily going to be 15 right now. So if it's greater than or equal to 15, we'll take that sum, divide by the number of rewards that we got, and if it's the same, if we've been doing it right this whole time, turn, or else don't turn. Reset our variables, and then this code down here is how we get that sum of the rewards and the turns, okay? So that's a basic explanation. I'm going to go ahead and run this. All right. All right. And okay, so let's go ahead and run this code, all right? We'll go ahead and run this code by saying, what did I call this? I called this demo. Right. So where did I put demo? Put it somewhere. Probably in here. Right. So Python, oh, so let me make this bigger. Whoa, way bigger. So Python demo.py, demo.py. So now we're going to run this baby. Boom, it's connecting to our local Docker container, which has our VNC server. WebSocket connection failed. Whoa, okay, let's see what's happening here. Let's see. Okay, so I'm going to close out this. Let's try that again. Sometimes if you open another window, it starts working. So, oh, okay, so WebSocket closing on handshake. Wow, this was working right before I started the live stream. Okay, so let's figure what is going on here. So, well, first of all, oh, okay, here's what it is. So on line 80 in main, forward in observation, line 80, what is happening? For observation in observation, let's see what's happening here. Environment.render. Okay, so what I've been saying here is else if turn forward for observation in observation. If you guys have suggestions, open to those too. Let's see what people are writing here. Okay, so, oh, capital F. That might be it. Is that what it is? Did I define it as a capital F? Oh, yes, thank you. Okay, so now let's run this thing, see if that, yo, yes, okay, awesome, yo, okay, awesome, yo, okay, great. So what it's doing, it's connected to our local Docker container using the VNC protocol, remember. So this is a kind of like a virtual machine, but it's inside of this Docker container as a VNC, using the VNC protocol. And so now it's going to connect to GitHub, and it's going to, let's see what's happening here. Come on, baby. Yes, you know what it is. So here's our game. It's about to start. It's going to load up, and then it's going to run our code. All right. Come on, Coaster Racer. You know what it is. Preparing graphics. How great is that? Preparing graphics. That's some Flash shit right there. Okay. Man, it's laggy, but okay. It's every 15 time steps. So iterations move fast in the game, right? So it's like 15 steps are happening every like second, okay? And as you can see, it's determining like, oh, if I hit something that I shouldn't be doing that. So randomly move in a different direction. If I hit something, randomly move in a different direction. It doesn't know like if it hits something on the left to move right, or if it hits something on the right to move left. But it does know if it hits something if it's not doing something right for 15 iterations, stop, okay? So there's the demo code. I'll let that run for a little bit. It's kind of laggy, but it's pretty cool, right? Boom, we've fallen, and it's just gonna keep on going. Okay, so I'm gonna exit out of that, and I'm gonna go back to you guys. Quit out of terminal, terminate as the terminator says, and then open up this Screen sharing. Okay. So last 5-minute Q&A, and then we're good to go. All right. Okay. All right. So a neural network is not in 11 lines of code, such as 9. This is my code, right? Yes, Mick. So Mick, yes, this is one of our challenge winners' code, Mick Van Holst. This was one of his entries for the challenge. I really liked it, and I wanted to demo it for you guys because I thought it was not hard enough that it was like gonna take like 2-3 hours, but it wasn't easy enough where it was like just like trivial. This was used reinforcement learning, and it was a good example of that. Where is the okay? Any good examples of Universe? I'll post some examples in the description. A tutorial on GAN. Search generative adversarial networks on YouTube. My video is probably the first one that's going to pop up. I'm going to do more in the future for sure. I'm actually kind of waiting for that to get a little better because there's a lot of possibilities with GANs. Like seriously, like generative models for video. Like, I mean, like we could generate movies and then say I want to be in this movie, assuming it was good enough and it had enough data. Like I want you to generate Star Wars, except put me in it and like not have Gungans, like not have Jar Jar Binks. Like that's the level of where we could get to. Like that's where I see the trajectory moving in generative models. It's incredible. With AI, if you can dream it, it's possible. If you can dream it, it's possible. Where did you learn machine learning techniques? On the internet, from machine learning subreddit, from Twitter, from implementing code myself on GitHub, from courses like Andrew Ng's course, and from the deep learning course on Udacity. How are you sure this code actually learns? Because it's receiving the reward and it's moving based on the reward. What's happening on Friday? Party? I can't answer that right now, but you're going to love it. What do you think of the new Apple paper? I'll give Apple. I still don't fully respect Apple yet, but if they keep going with this this open source stuff, there's some potential there. How did you get your first 10 YouTube subscribers? Just by posting videos, even though people didn't like them that much. I just believed in myself. I just like a positive feedback loop. Practical application for this. For this specific bot, any kind of racing game that's moving left and right, this could be applied to. Did you check Song Han's paper? Hitesh, not yet. I've been really busy. But I will. How to be a good programmer. I'll make a video on that. Watch all my videos. Suraj, custom voice assistant video. Custom voice assistant. That's a good question. I haven't done voice specifically, like a voice assistant. I've done build a TensorFlow chatbot, but not a voice version of that. So that's going to come up. What do you think of Microsoft Azure ML? Actually, Microsoft is surprisingly starting to get cool again. I mean, it's incredible, like what Satya Nadella has done. He's taking Microsoft in a different direction. So I'm yes, Mick, I'm gonna add the link to the descriptions. Hey Suraj, what's next? Guys, just wait for Friday. Wait for Friday. Seriously, like wait for Friday. Are you going to do interview videos? Yes, I'm gonna do those soon. Yeah, I mean, it's not in the immediate plan. Maybe in two weeks. Rap on Universe. As always, I've got a rap. Okay, so rap on Universe. Okay, I've got a game bot. I do it without a thought. I look at the future and think, man, I got to go away from here and find my flow. Man, my world is so high. I'm so in the sky. I'm like a universe. My mind is so insane. I'm like a fly on a wall as the universe comes down with planets. My. Okay, that was it. That was my, yo, be hyped, man. Yo, get hyped, get hyped, get hyped, get super hyped, because this is huge. I am meeting some important people today. Okay, so are you vegetarian? No. Okay, so bars. Okay, so have you looked into hierarchical temporal memory by Numenta? Yo, Numenta, as great as Jeff Hawkins' book on intelligence is, and as much as I love the idea of artificial general intelligence, Numenta hasn't really done anything. It hasn't published results that compare to DeepMind, and they're kind of a joke in the community. So, yeah. And also, there hasn't been any real innovation. I mean, people have known this, this kind of hierarchical thing happening in the brain. But anyway, so Elon, Hype equals hype, Elon. All right, cool. So, yo, it's 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 not Elon, but it will be. Not yet. Not Elon. Eventually, maybe later this year. I'm taking my time. I know it's gonna happen. We're gonna it's us. You know what I'm saying? We are a squad, guys. We are an army. We are a force. We are a movement, and we are gonna get everybody. We are gonna get the attention of the entire world. Okay, we are gonna get the attention of everybody because this is a warpath that we are on. We're gonna solve intelligence. Okay, so that's it for this video. I love you guys. Thanks for watching. And for now, I've got to go start a revolution, or sorry, continue a revolution. So thanks for watching.